Hello friends, this is my first lecture in the series DS and Algo for Competitive Programming. Today I'll be covering binary search in detail. I'll try to cover theory quickly and then we can jump on to the binary search algorithm. In the subsequent lectures, we will be covering different problems that can be solved using binary search. So join me on this journey of mastering binary search. Okay, so what is binary search? The definition that you can see on the screen is from Wikipedia. It basically says that binary search is a search technique that finds the position of a target value within a sorted array. Actually, we can use binary search with any data structure that allows us to access its element using indexes in constant time. In Java, you can perform binary search on sorted array lists as well. Array lists internally use array for storing elements and hence it allows constant time access to any index within the array. So if in future you come up with any data structure that fulfills this criteria, you can use binary search on that. Now let's talk about how binary search works. Binary search compares the target value to the middle element of the array. If they are not equal, the half in which the target cannot lie is eliminated and the search continues on the remaining half. Again, taking the middle element to compare to the target value and repeating this until the target value is found. Now let's understand the description from Wikipedia in layman terms. In binary search, at each step, we divide the array into two equal halves and then we search for the target value on the relevant half. We do this by choosing a pivot value which lies somewhere in the middle of the array. And then we look for the target value either on the left or right side of the pivot value. Now let's consider the example shown in the video. In this example, the target value that we are looking for is 23 and our array size is 10. At each step, we find the pivot value and then look if the target value is equal to the pivot value or is it smaller or larger than the target value. The formula that we use for finding the pivot value is left plus right by 2. So we take the sum of the leftmost and the rightmost index and then we divide it by 2. Let's now go step by step over the example and find the target value. For the first step, the leftmost index is 0 and the rightmost index is 9. So the pivot value is at index 0 plus 9 by 2, which is 4. The value at index 4 is 16. And if you compare it with the target value, we can see that the target value is greater than the pivot value. And we know that the array is sorted in ascending order. So we need to search for the target value on right side of the pivot value. In the second step, we look for the target value in the subarray starting at index 5, which is index of the pivot value from previous step plus 1. So for the next step, the index of pivot value is 5 plus 9 by 2, which is 7. The value at index 7 is 56. And we know that 23, our target value, is smaller than 56. So we will now look on left side of the pivot value. In the third step, we have to look at the subarray starting at index 5 and ending at index 6, which is index of the pivot value from previous step minus 1. And if we calculate the pivot index for this subarray, it will come down to 5. And the value at index 5 is 23, which is same as our target value. So we return 5 in this case. Okay, now let's talk about the time and space complexity of binary search. As you can see in the video, time complexity for binary search is order log n. At each step in binary search, the number of elements we look at is reduced by half from the previous step. And if you calculate it mathematically, you will find out that we require order log n steps to find the target element. And hence the time complexity of binary search becomes order log n. Now let's look at the space complexity of binary search. The space complexity of binary search is order 1 for the iterative approach, whereas it is order log n for the recursive approach. In an iterative approach, we just need to keep track of left and right variable, and we might need an additional variable for storing the middle value. So just by using the left, right and the middle variable, we can perform binary search iteratively on a sorted array. If we talk about the recursive approach, recursion internally uses stack for storing method reference and method local variables. The size of the stack depends on the number of recursive calls, which in turn depends on the number of steps in our search. And as already explained, the number of steps required to find a target value using binary search is order log n. So the space complexity of our solution also becomes order log n. Now let's talk about my solution. But before that, I would request you to please try it on your own first. In the description section of this video, I will provide a link where you can solve this binary search problem. Please try to solve it before proceeding further in this video. Let's go through the code line by line and try to understand what we are doing here. This complete code is pushed into my GitHub repository. I'll provide a link to my GitHub repository in the description section of this video. So as you can see on line number 12, we are provided with an array and a target value that we need to find in this sorted array. On line number 16, in the first step, we choose 0 as our leftmost index and the rightmost index is size of the array -1. Okay, and this is the method that I'll be calling recursively to find the target value. Now on line number 23, you can see that if the left index is equal to the rightmost index, you basically check if the value at this index is equal to the target value. If it is equal to the target value, we return the index, otherwise we return -1. Because in this case, the array you are looking for has a size of just 1. And if that element matches the target value, you return its index, otherwise you are unable to find this element in this array, so you just return -1. On line number 30, I'm trying to find out the index of the middle value, the central element. Okay, now on line number 32, I check if this middle value is equal to the target value. If it is equal to the target value, we return the middle value, and if it is less than the target value, okay, then we basically look for in the right side of this middle value, and if the middle value is greater than the target value, then we look for the target element on left side of this middle value. Okay, as you can see on line number 36, if the target element is smaller than the middle value, so we basically keep the leftmost index as it is, but we change the rightmost index. Rightmost index now becomes mid -1. Okay, and if the target value is greater than the middle value, we basically change the leftmost index. We make it mid +1, and the rightmost index, it remains the same. And we are basically recursively calling this method until we find our target value. Okay, now let's talk about the edge cases and the solution. As we are dealing with array and we are dealing with indexes here, there is always a possibility of getting array index out of bound exception. On line number 20, you can see that here I am handling a case where your leftmost index is actually greater than your rightmost index. Okay, or in other words, your rightmost index is smaller than your leftmost index, but this represents an invalid subarray. So in this case, I just return -1. Okay, on line number 23, this actually represents a case where your array or your subarray just has one element, and then we basically check if this element is equal to the target value. If it is equal to the target value, we return the index of the element, otherwise we return -1. Okay, and the other steps I have already explained in the previous section. I hope I was able to give you good idea of binary search and how it works. So that's it for this lecture. For the next few videos, we will just talk about binary search and different problems that we can solve using binary search. I'm sure this will help you in competitive programming or cracking coding interviews. Hit like if you like the video and subscribe to my channel. I will come up with a new video as soon as possible. Till then, goodbye.